Hi, this is Mr. Anderson, and this is our second video talking about what makes one atom different from another. In our last video, we took a look at protons and electrons, and we figured out to find those, we need to look at the atomic number. The atomic number is always the smallest number in an element box. Protons are the identity of an atom that can never change. So for carbon, we know because it's got this capital C, that it always has 6 protons. Now the number of electrons can change in chemical reactions. However, because this is from the periodic table, we know that it is neutral, which means that it has 6 positive charges. And if it has 6 positive charges, there have to be 6 negative charges. So we know there's 6 protons and 6 electrons. The question, however, that we did not answer was how many neutrons does the atom have? To find this, we have to start a different conversation. We need to talk about mass. There is a difference in the mass between these particles. In fact, there's 1,000 to 1 difference. So I like to use this analogy of the elephant and the flea. So protons are kind of like an elephant. They're huge. They have a lot of mass. And you know what? So are neutrons. Neutrons and protons are both huge. They're the 1,000 here. They make up the mass of an atom. Well, and you're saying, what about the electrons? Well, the electrons are extremely small, even for a particle. They're the 1. While protons and neutrons are kind of like elephants, electrons are kind of like fleas. They're very, 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 very tiny, even for a particle. And while they do have mass, their mass is so small that it really doesn't make a difference for the atom. Think about if an elephant were on a scale. It'd have to be on a really huge scale. Now think about if a flea jumped on the elephant while it were on the scale. Would it really change the measurement of the elephant? And while we know theoretically in some very tiny, small, insignificant way it would, it's not enough to matter. And this comes into play here because when we're looking at neutrons and trying to figure them out from the periodic table, we have to deal with mass. So, we need to talk about this big number in our element box. This big number is called the atomic mass. This atomic mass is made up of protons and neutrons. So protons and neutrons go together to make up the mass of an atom because they're huge particles. Before we move on, I want to mention that there's also another name for atomic mass. It's an older term, but you'll still find it used in videos and in textbooks. It's atomic weight. Atomic weight and atomic mass refer to the same thing. More physicists and chemists in modern times have moved away from weight because they recognize mass and weight are actually different things. That's a different conversation for another day when we're doing physics. Today, however, we want to figure out how we measure the amount of neutrons in an atom. And this is where we bring in our formula. Okay, here's our formula. I had to move some things around on our screen to fit it all together. But here's how it works. Notice this box here below our element. To figure out the number of neutrons, we take the atomic mass, which in this case is 12. It's always the largest number on the atom. And we subtract it by the atomic number, which is, in this case, for carbon, 6. And you great mathematicians out there, you know that 12 minus 6 is 6. So carbon has 6 neutrons. Cool. Now, a word of caution. I know you're looking at this box right now and you're thinking, gee, it already said 6 up there. Why did I have to do this math? Why did I have to go through this process? And the answer is, this number doesn't always work out the same for everything. So while in this situation, 6 happened to be the number of protons and electrons and neutrons, that's not always how it works. There are going to be situations in where it's a different number, so you have to go through this subtraction process to figure it out. All right, so now let's go back and tie this into our atom model, because now we have all the information we need to complete our carbon model. All right, here's our carbon model. Remember, our atomic number tells us that there are 6 protons. We'll move those over to the nucleus. And we remember that to find the number of neutrons, we took the mass, 12, and subtracted the atomic number of 6. And that gave us 6 neutrons. So now we can also move these neutrons into the nucleus, because protons and neutrons are both in the nucleus of the atom. And this is where the mass is that makes up the atom. Remember, this nucleus is the center of an atom, which is different from the nucleus of a cell. A cell's nucleus protects its DNA. All right, so our last part, we have 6 electrons. 6 electrons that are so small, they have virtually no mass at all. So they do not make up the mass calculation. However, they are very important charges, because protons have positive charges and electrons have negative charges, and they balance each other out, even though there's a huge difference in size, 1,000 to 1. So you remember, of course, that we can only fit 2 electrons on the first energy level, also known as an orbital, also known as a shell. And we have to put the remaining 4 on the second energy level. And there we have it. Here is our atom model for carbon, with its protons that have a positive charge, the neutrons that have no charge, and the electrons with a negative charge. Thanks. Till next time.